CAST Director of Research Gabrielle Schlickman provides background knowledge for understanding students' skill levels in different contexts.
Under UDL, we understand learning to happen in the interaction of the individual with the environment, actually in the transaction between those two things. It's deeply social and contextual, and for that reason it's very important to understand how a person's knowledge shifts and changes as they interact with the environment. In the developmental and learning sciences literature, we talk about two knowledge states that happen in the context of learning. One is a person's functional level of knowledge, and that is what they can do on their own without support. The other is their optimal level of knowledge. That's what they can do in the context of a highly supportive environment. They can do even more if they're under scaffolding conditions, where they're working directly with an expert who's co-constructing the task with them. It's important to think about these shifts and changes in knowledge relative to context as not being sort of illusory departures from what the person actually knows. In fact, that is the knowledge they have under those conditions. You can think about this in the context of teaching. It's very important to understand what a student can do on their own, what they can do with support in the environment, and what they can do under scaffolding conditions, because that will define where the teaching needs to happen in order to allow the student to progress with their learning. Several theorists within the developmental and learning sciences have described this, both empirically and theoretically. The originator of the idea was Lev Vygotsky, who came up with the concept of the zone of proximal development, that is, defining the sort of range at which a learner can have their optimum progress toward learning. You want teaching to happen in that zone. Others have described it more empirically, for example, Kurt Fischer, who actually came up with the terms functional and optimal knowledge. And has described empirically how a learner's understanding progresses under different conditions. Here's an example of what a learner's knowledge looks like under different kinds of contextual supports. This is a study that was conducted following adult learners working in dyads as they were trying to understand how a robot was constructed and as it reacted to light. And as you can see, as they work together, their concepts are changing. So the skill level is on the y-axis to the left, and time is represented at the bottom. So you can see how their skill level changed over time. It's not consistent at all. It doesn't go up progressively. In fact, it goes up as they build a skill, and then when a new variable is introduced, like the light with the robot, as you can see by the dotted lines, they actually drop down in their skill level, and it's not the same as what they knew before, and they have to reconstruct that skill. Here's another example from my own work. We were trying to understand how modeling for students operates on their concepts. So in this case, we were working with kindergartners and second graders. And what we did was we had them work with objects and experiment with them in a tub of water. And they were asked to give a prediction about whether the object would sink or float, and then to experiment with whether the object would sink or float, and then provide an explanation of why the object sank or floated. We mapped their concepts over time, and then we offered a model of support to half the children, giving them an explanation that was a little higher than their skill level, but not right where their thinking was on the functional level, what they could do on their own. And what we found was a few patterns emerged. Some students didn't change at all, and those were typically the students who had low performances. So really that level of contextual support was too high from them. They weren't benefiting from it. Most of the students exhibited this up and down pattern, where their concepts raised up, their skill complexity in terms of how they built an explanation raised up after the model support. But then it dipped down, and then it came back up again as they experimented with the objects. They basically, or the idea was that they created this sort of mental model from the model answer that we provided with them, and struggled with that then after, as they interacted with the objects, building and rebuilding the skill over time.